Welcome to Green Giants, Titans of Renewable Energy, the podcast where insights and innovation meet. Every episode, we dive into conversations with industry leaders, experts, and change makers, bringing you the stories and ideas in the renewable energy sector that shape our world. And now, let's jump into today's episode with your host, Wes Ashworth. Welcome back to Green Giants, Titans of Renewable Energy. Today's guest is Frank Tybor, Chief Technology Officer at Infravision. And this conversation is about one of the most overlooked bottlenecks in our energy future, which is transmission, the power lines that move electricity where it needs to go. Frank's background spans SpaceX, Energy Vault, ThinkOrbital, and now Infravision, giving him a rare perspective on what it takes to turn complex technology into real-world infrastructure. We talk constantly about solar, wind, batteries, AI, data centers, and electrification. But none of it works if we cannot move electricity from where it's generated to where it's needed. That's the challenge Infravision is taking on. The company is using drone-enabled robotics, intelligent ground equipment, and integrated field systems to rethink how transmission lines are built, making construction faster, safer, and more scalable. With that, Frank, welcome to the show.
Thank you. Excited to be here.
Yeah, it's a pleasure to have you on. As I've said before, it's a topic I'm really interested and intrigued in what you're doing and want to get all into that. But we'll start a little bit with your journey. So before we get into grid bottleneck and the technology Infravision is building, I want to start with your own path. So you've not maybe had a conventional energy career. You've worked on rocket launch pads and drone ships and energy storage, aerospace systems, and now transmission construction. And what ties all that together is the ability to take these complex systems out of theory and make them really work in the real world. What first pulled you into the world of transmission and grid construction? And what's kept you there, once you saw how the system actually operates?
Sure. So like you said, my background tends to be where there's not one single engineering discipline that's necessary to solve a problem. SpaceX was quite literally landing rockets in the middle of the ocean. So you had to understand aerodynamics, hydrodynamics, marine offshore equipment, and then also looking at a big problem that many people said was impossible to solve. I think grid construction is really right there as one of these big problems we're coming to just as a world. A little bit of background. It wasn't that long ago where you always had about 10 years to build a new power line because that's how long it would take to either build the load or the power generation. Normal power plants, at least 10 years to build, if not more. So it was never an item for rapid construction. Fast forward to now where you can build a 14 gigawatt solar field in a year, or you can build a giant data center in much faster than a year. And these items need power and they need it quickly. So, for me at Infravision, that's really where it's exciting because we have to pull a lot of disparate engineering techs together and we have a really significant problem that needs to be solved right away.
Yeah, it's incredible. I love that you're drawn to these kind of like big, somewhat, impossible. I say that with quotations. These huge problems that you're able to take on and really make them come to life and see that. And this is again one of the biggest ones out there as we're learning. Was there a moment where you realized the way we build the grid wasn't just inefficient, but it was just fundamentally incapable of scaling to the future demand you're talking about there?
Sure. So the way we built the grid was optimized for when you had a long time to solve these problems. What you immediately look at is how are large power lines put up? And that's usually right now, you have a helicopter and it does a very precision flight operation where it tows out a steel cable, it latches it into every tower. And then that is progressively what you use to pull up bigger and bigger lines that eventually becomes a power line. The trouble with that is it's a flight regime that helicopters don't like to operate in. They're very low to the ground. They're very high power. So the potential for injury there is quite high. If there's anything that goes wrong with that helicopter, it's not going to be able to auto-rotate. And it's also a skill that isn't common. There aren't many pilots who can fly that. So when you say, hey, we want to build the grid quickly, it's not just turning on a switch. It's quite literally saying, well, there aren't enough helicopters, aren't enough skilled pilots. And even if there were, this just isn't a scalable technology. So that's when it became really interesting to me, like, oh, this is a huge problem as a world. This is a solution that we really haven't been iterating on for the last 30, 40 years. And there is a need for innovation.
Yeah, no question. And as you painted out there, it's not the most efficient way to do it, also not the safest way to do it. And, not a lot of people want to do it either as well, too. And then you got, of course, cost concerns to factor into that as well, too, with helicopters. It really does capture the gap between today's infrastructure and really tomorrow's demand and what you're seeing there. So I mentioned this obviously in the intro throughout. So before joining Infravision, you held impressive roles at SpaceX, ThinkOrbital, and Energy Vault. How did you become interested in just the scale of the global transmission challenge, and maybe what stood out to you specifically about Infravision, and I know Cameron's vision and leadership that convinced you this was just a challenge you wanted to begin tackling and really sink your teeth into?
Sure. Going straight through that question kind of in reverse order. We're very fortunate. Cam, our CEO, founded our company based off a need. He used to be a helicopter stringing engineer and saw these accidents firsthand. Was, oh, this is not a good way that the world is doing this. How can we do it better? And he's really been, I think, able to articulate the vision clearly and say, we as a company are willing to change the world. That's a bold statement, and lots of people like to say it. We're willing to do the hard work, do the investment, and we've both got the orders as well as the financial backing to pull that off. So, I think it's an articulated willingness to change the world, change the status quo, but also the resources to do that is pretty exciting to me.
Yeah, I love that. That's extremely exciting. That vision, passion behind it, and the ability and those sort of things too, just to change the world. Not many people are able to really take that on boldly and actually work on that problem. So I love it. So what's the biggest misconception? If we think about the world today, sort of policymakers and investors, what are those biggest misconceptions around that's just the practical limits of how fast grid infrastructure can be built today? Like, what's the current state of just that with policymakers, investors from their perspective?
So I think probably the biggest misconception is that the power transmission is this easy afterthought that says we'll build a data center or we will just build a solar field. Yay. A solar field is typically in a desert. It's a long way off from where the power is needed. And so let's just put up power lines isn't that simple. You're usually going over rough terrain. You're usually very mindful of the environmental impacts of what you're doing. And all of that just takes time. It takes energy, and it is a big cost factor.
Yeah, absolutely. It's such an important reality check. I think, policy targets, capital commitments can move quickly, but steel, crews, rights of way, aviation approvals, outages, construction sequencing move at a very different pace. So good to point that out. If someone, say, had dropped you into today's energy transition conversation 10 years ago, if you go back in time there, what would have surprised you most about where we are now?
So I think the rapid demand in load is probably one of the biggest single transitions that I don't think anyone saw coming. And not just that, but the rapid demand for load that is almost cost agnostic, where the penalty for a data center not switching on is very, very massive. They're giving up huge revenues daily. And the degree of reliability these assets need are very, very high, which means you're usually not just running one power line, you're running multiple sources so they can hit the reliability targets that they're promising. So, 10 years ago, it was, we have load demand. It's going to grow, but no one, I think, expected it to grow in the exponential that it has.
Yeah, which is the reason we need new solutions and where your technology comes in. So, we've kind of painted the picture. We have this massive sort of macro problem, more generation to connect, more load coming online, more pressure from data centers and industrial growth, and an aging grid that needs to be expanded and modernized. But the bottleneck, again, becomes very tangible when you look at what it actually takes to build a line. And so let's get this out of abstract and into the construction process itself. And so once a new transmission line is approved today, what actually has to happen to construct a line?
Sure. So I think there's a lot of steps involved, and I'm going to gloss over a few of them in the interest of trying to make this quick and focused on a lot of what we do. But there's obviously the full right-of-ways, the environmental approvals, foundations, mobilization for towers. And then where we come in is the towers are up. At that point, you put on pulleys. They're called stringing blocks along each tower. And these will be what the pilot lines are flown into, so that a helicopter will fly a small line. And very progressively, you pull back and forth with these small lines, let's say 1/2-inch steel, up to larger 1-inch steel cables. And then that's what you actually pull the multiple conductors through. Once all the conductors are up, then you cut off, basically install insulators, clamp. And after a lot of very labor-intensive steps, you're left with power lines on these towers. That's part A. Part B is these are not static assets. So there's ongoing inspection, there's ongoing monitoring of how these systems are doing. And because of the ramifications of a power line going down, a lot of ongoing preventative maintenance trying to identify problems so you don't have these large outages, blackout events.
Yeah, it helps make the complexity tangible. A transmission project is not just one big construction step. It's a tightly sequenced chain where each step can slow everything else down. And so there's a lot of that. I guess when you're seeing it now, like where specifically does the process break down? Is it labor, permitting, logistics, or something deeper?
So I think a lot of it is labor based.
Yeah.
This is a skill set that isn't common and you have to train people to do. Building the actual towers, I'll say that's relatively common to any construction site. It's large steel construction. But it really is in the power line stringing where this hits its bottleneck. You have to get those initial pilot lines up, and then you have to step up to the power lines. And this is where a lot of the skill is involved, especially in what's called tension stringing. So there's two ways you can string a power line. One is typically what would be called carpet stringing, where essentially you drag the power line tower to tower to tower. This is kind of an older method, and it's one that is really going out of fashion just because of the amount of land you need to clear. And especially if you're in environmentally sensitive areas, the amount of potentially trees, rainforest, indigenous habitat that would be affected. And so this becomes tension stringing. And tension stringing requires a lot of sophisticated skill, winches, and know-how to basically hold back pressure on a power line as you're towing it from tower to tower, keeping the sag right so you can do this without affecting vast swaths of land.
Yeah, so again, tons of complexity there. Again, the labor component, a big piece of that as well too, and where you're coming in. And we know transmission construction remains one of the least digitized and least automated parts of the energy system. Why hasn't it maybe seen the same productivity gains as we've seen in solar and semiconductors and other industries, for example?
Sure. So basically, for the longest time, that need to innovate hasn't existed there. You've had the time. You've also been able to absorb the cost. These are large projects that will last for a very long time. So them being slightly more expensive isn't, to the consumer showing up in your utility bill, isn't a big effect. So there hasn't been a huge push for innovation. And I think it's really only up until the last few years where there is massive demand side pull that is saying we need innovation here because it's really, really impacting the bottom line. You mentioned microprocessor fab, great example. Microprocessor fabs need a lot of power. And so there's this huge demand that says, well, we either have to spend a massive amount on backup generation, diesels, which we probably still can't get, or please get us a power line now.
Yeah, absolutely. And again, sort of that in the moment, right? The demand increasing. It's just, it worked at one point, not today, not where it's going. And that's just continuing to accelerate just at this kind of breakneck speed as well, too. So obviously, as we painted the picture and told the problem, like more solutions are needed. And this is where your technology comes in. And we did talk about like a little bit on the labor side of the equation, like workforce shortage, I know is always a big concern, especially when you're thinking about the way it's done currently. How is that problem maybe mitigated a little bit or solved with your technology and the use of drones and other technology and software that you're using?
So I think I'll answer that slightly circular way. And so our technology is drone based. So we use drones in place of a helicopter to put up the very first lines from tower to tower to tower, the pilot line. And then we'll use that to pull up progressively bigger lines. We usually have one or two steps ahead of what a helicopter might, just because the drone isn't as powerful. So we have to fly these smaller, more advanced synthetic lines. And then we will, once that is up, the process doesn't look too dissimilar from what you've seen. As far as our skilled labor demand, mobilizing a helicopter to a remote region of the world and the support crew is a very specialized crew, and it's challenging. Let's just say remote areas of India. That means you're mobilizing a full aviation maintenance asset, a full aviation ground support setup, as well as a very large number of skilled personnel to support the helicopter. You've got these large winch drums, and as the helicopter pays out, you've got skilled labor making that cable pay out at the rate the pilot wants. We've been very fortunate to automate almost all of that process. So we have a very intelligent robotic winch sitting on the ground that's in constant contact with the drone. So as it pays out, it makes sure the drone has the right amount of a specialty rope that it needs to perform its mission. And this really takes the number of people you need for this challenging step down massively. And drone maintenance, especially in remote parts of the world, is a whole lot easier than full gas turbine helicopter maintenance. We can do a lot of things that a helicopter stringing company can't. We can mobilize a fully redundant backup set of everything. So, when we're in the field, we can be working. And this might sound mundane, but aviation gas in certain parts of the world is incredibly hard just as one item, let alone doing a 100-hour maintenance inspection on a helicopter.
Right. Yeah. That was what was, enlightening for me. It's like the more I dug into this and researched just how much sense it makes. And you're just like, oh my gosh, this is the right solution. Like, what's the size comparison even? You think about that of like a drone that you're using versus the helicopter that typically is doing the job. What's that comparison like?
Well, yeah. So I think that's a great example. And there's something I'd say we're very proud of. We have one of our drone utility vehicles. So it's an F-550 pickup truck where it has the winch, a drone compartment, a hangar, and all the stuff a team would need, a sort of compartmentalized, ready to go on a Ford F-550. And one of those is on permanent lease with Pacific Gas and Electric. They're their own owner operator, and they have that so they can respond very, very quickly in the event of any storm, outage, natural disaster. Essentially drive to site with everything they need to put up a power line again. That's an F-550, which, yes, it's a big truck, but it's not a semi along with a helicopter. So I think that responsiveness is really nice to our customers here in the US, but is a huge benefit both in time to get to site, resources needed, and overall execution on the project.
Yeah, so many advantages there. Even that, and being able to mobilize quickly and weather events and things like that where you need to get out there. So we've talked around this a little bit. You talked about the demand, the current way we're doing this and not quite being enough and not able to scale to the level that we're going to need. When you zoom out, globally, like how big is the gap truly between what we need to build and what we're actually capable of building right now if technologies like yours didn't exist?
Well, I think that is a very broad question. And, I'm trying to put it in some terms that are manageable. Picking on Europe for a second, almost the entire grid of Europe is going to need to be rebuilt in the next 20 to 30 years as it starts aging out. There's some plus or minus on that, you could argue, but that's a massive scope. The US isn't too dissimilar as our grid starts aging. So, there's enough work to keep us busy for the foreseeable future as aggressively as we're scaling. But I think this is not just we need to build new capacity to support all these new innovations coming on. But even what we've built is starting to age out. It's 60, 70, 80 years old. So yes, it's a huge problem globally.
Massive, yeah, beyond a doubt. So you're in a good spot. Lots of demand there. A huge, bright future ahead.
We are in the unique place, and I think it's wonderful where we're not developing technology for the sake of abstract technology. We have customers that want this done yesterday, last year. And so it is, from an engineering perspective, it's really satisfying to see that was a new design in CAD 6 months ago. Well, now it's out making an impact.
Absolutely. What's the true risk, right? Of where, if you think about this, where you could easily see that transmission becomes this sort of like the single point of failure for the entire energy transition, AI growth, electrification, even US industrial resurgence and things like that. What's your take on that? Do you feel like we're underestimating that risk? And what's your thoughts around that?
I don't think we're necessarily underestimating that risk, but we are starting to see companies respond in their own ways. And we're starting to see the limits of that. New data centers are coming online. They can't get the power they need. So they are mobilizing microgas turbine arrays, any gen sets they can find. But even those are now starting to become very, very sparse and limited. And a lot of times that's the pacing item on a data center, which I find amazing, is it's not the core technology, the chipsets, the GPUs. It's where is a gas turbine, which is remarkable. This is not new technology. And so I think we are adapting as an industry, but at this point, those items are pacing. So I think it's, we will just see it as limits to growth.
It's a great way to frame it. I'll ask this another way. So if nothing changes starting today, and technologies like Infravision didn't exist, so no step change in how we build, what would the grid look like in 10, 15, 20 years?
I think that's a really interesting question. And what you would really see is, I think, some suboptimal reliability where, if you can't get the transmission up, you're not going to be able to have the resilience you want. So the grid won't have the frequency stability, the load stability that customers expect, which means blackout is much more common. The other thing I think you would see is a lot of local centralization versus ability to transmit power across the country. I think right now we're fortunate that we do have a nice national grid where if there is excess capacity from wind turbines in North Dakota, there's probably a user for it somewhere else in the country. That relies on a national stable grid system. As you start getting centralized, it becomes a lot harder to pull power from where you have it to where you'd like it.
Yeah, it's a good, honest picture, and I like to kind of look at that, because the consequences of that are not abstract. They show up as delayed projects, constrained growth, reliability issues, as you said, strain of generation. It really shows the need for why this is here. So now that we've kind of established that, we've really gone into just talking about the bottleneck and really understanding it. I want to move into the Infravision approach and dig more into that, because what's compelling here is you're not just making a better piece of equipment. You're trying to really build a repeatable construction system, combining drones, the ground equipment, line hardware, control software, and trained crews. So it's a very different mental model from saying, hey, just use a drone instead of a helicopter. There's a lot more into it. So against that backdrop, what is Infravision fundamentally trying to change about how grid infrastructure gets built? And we've talked about this, but anything else to add just in terms of why hasn't that changed already?
Sure. So Infravision's thesis is build the grid better, faster, cheaper. And our kind of North Star is 10x better than what's currently available. To that end, I think it's fun to talk about, Infravision's founding, which was, well, why don't we just get a drone to do what a helicopter does? And it's really not that simple. This is a full system where you've got a helicopter, a rope, and a ground system, this case, a helicopter-based winch, that was all sort of co-developed, and they all work together. So you can't just put a drone in place of a helicopter and have it work. The pulleys that you're flying into on every single tower were designed for a helicopter. So if you say, okay, well, let's use a drone. The drone obviously can't pull as hard, so you're going to need to get a smaller, lighter rope. The smaller, lighter rope is now flying into a helicopter pulley that it was never designed for. And the existing ground infrastructure also isn't going to work. So if you start looking at this, it's not possible to make an impact by changing one thing. You have to engineer the whole system. And that's what Infravision has both had to do and been really fortunate to do, because that's given us an opportunity to optimize and improve every step along the way. So, there's the drone element, very important, but we're not the only company that uses drones in the world. That's one piece. Then there's the line hardware, all the stuff under the drone that can interface with the towers and ultimately leave a power line. And then the ground system and the support equipment. So we have had to develop a specialized high-speed electric winch. It is highly automated, highly robotized, such that it's talking to the drone and helping those two perform the function. So, this is really big, where the pilot is flying a drone. A lot of these complex abstractions are sort of removed from him, so he can do his job as best he can, and we can put that up. But I think even in talking about that, there's a whole element of learning how to do an effective drone operation, working with the appropriate regulators to get this approved. And then we do have our own logistical challenges of, well, we need airspace clearances, we need the right command and communications because we do push a lot of data back and forth. And so there's a lot of other technologies that Infravision has had to develop to get us to where we are today.
Yeah, I love this innovation and just rethinking the whole system and just how all these pieces work together and just looking at the problem differently, like creating a completely whole different solution that's all those different pieces, all those different elements that you mentioned. So I love it. It's not just improving the one tool, as I said, you're just redesigning the workflow around the whole new, bigger and better system. Let's see, for someone hearing about Infravision for the first time, what does your proprietary drone-enabled system actually do on a live transmission project? Just help us understand that a little bit better. You've talked about it a bit, but just kind of give us that full mental picture of what's actually happening.
Sure. So I think the best way to envision that is you would see a small team show up where there's power poles set up, but no power lines on them in a large pickup. Guys are going to fold out a custom drone and then hook it up to a custom line and start flying down the relative easement. As they're flying, each of these towers has what's called a helicopter stringing block. It usually has a lot of little rollers because you're usually pulling quad or hex bundle. And the guys are basically going to take that rope and latch it into each tower. So what you would see on any given day is a flight crew towing out what looks like a very small rope, latching it into all these towers, and then pulling back larger and larger ropes back and forth. What you would actually see on site is not too different than any drone flight operations. The guys are going to do a flight, they're going to tow the line out, they're going to come back, change batteries, download flight logs, and continue. What is actually going on frontline? Just drone flight ops. Behind that is high power electric winch, it's high power electric systems, and a lot of data flows. So, we're very fortunate to be getting all this data streamed back to us in engineering to say, oh, yay, we're optimizing processes correctly. Our winch control loops are healthy, our data flows are healthy. And ultimately, that means we are able to go out and do a job safely, succinctly, and really deliver value for the customer.
Yeah, absolutely. It's so cool. It makes it much easier to picture as you walk through that. And what I'll do too, I'll try to link some videos and things like that in the show notes as well too, for people that want to kind of see that visually. Love that. So when you're attacking this problem, I guess what part of the construction process did you decide to maybe attack first, and why that piece? What was the starting spot?
Well, so again, very clearly, it's the pilot line stringing. It's the first line that gets up tower to tower to tower. As far as building transmission towers, that's a relatively mature technology and it's doable. Once you have the power lines or the pilot lines up, it's possible relatively easily using existing tech to go ahead and get up to a full conductor. But that actual pilot line stringing in most of the world means helicopter or TBD tech. And I think to give you some of the examples is we had to string new power lines over I-35 freeway in Texas. It's the main artery into Austin. So, to say, hey, we're going to close this freeway down for blank amount of time isn't popular. When it's, okay, I've got a drone towing a small diameter line, I can do that quickly and then get everything back to normal. That's, I think, the vision to have in your head is large rivers, large gorges, where you've got to get this first step over and done is where, we were founded to do. And that was kind of the big, I think, everything starts with that pilot line.
Absolutely. It makes so much sense. It sounds like you went after that step where the current method had real limitations, especially around safety, access, scalability, given some of those examples. So we've talked about this as well throughout, but I want to see if we can get some, more concrete numbers. I know it won't be exact, just sort of, from your perspective, thinking about the current solution versus your solution, how much just faster, safer, more affordably can transmission be built using your approach versus those traditional methods?
Sure. So I think what I will say, the first question is, can you build using traditional methods? And that's not always a given. There are regulatory environments where helicopters can't fly or have severely limited flight envelopes because of what we talked about previously, the risk hazards associated with this. There's also the very high, very remote areas that are not suited to helicopter. So I think, that's kind of checkbox number one of, hey, these are jobs that weren't previously permitted. A lot of noise ordinance, noise restrictions. A drone's an awful lot quieter than a helicopter. So this is appealing to when we're doing stringing in urban environments. So I think that's kind of point one to your question. Speed wise, a helicopter is fast. That is a good way to fly. But Where we're sort of proud is we can match the speed of a helicopter and we can get more flight hours in a day because we're not having to stop to fuel, pilots. It's easier for us to swap pilots. It's easier for us to swap drones. So, in an operations day, we can go toe to toe with a helicopter slightly ahead. But then it's really in the cost targets at the end of the day where that's where we're very proud because I would love to get my helicopter flight license. I was actually looking at this the other day. The cheapest helicopter I could rent was $700 an hour. And that's not the one that's doing power line stringing. So, that's where the cost numbers really start showing up is like, this is compelling, like smaller team on site, smaller footprint, all of that really adds up at the end of the day.
Yeah, absolutely. And to your first point, I like that you went there. Like these are these circumstances where it wouldn't even be possible with the older technology that is now possible with drone technology and what you're doing. So I love that. And just cost comparisons as well. We haven't talked about even the carbon footprint, running a helicopter and fuel and all that's involved there as well too, added benefit as well too. So love that, all of that. Again, seems like pretty well no-brainer solution for me looking at it. What surprised you most? I guess when you started deploying this in the field, where does friction start showing up? Like what were some of those early hurdles that you had to get over?
Sure. And I don't even think it's necessarily an early hurdle. It's an ongoing hurdle this is a risk avoidant world. Power lines, utilities are very, very risk adverse as they should be. And it's a industry that has a mature technology stack. A helicopter stringing has been proven and, it's built the grid that's powering our conversation. There's a pedigree to that knowledge. To me, a lot of this feels very similar to when I joined SpaceX, where at the time people were laughing at this, small startup. This was 2011, long before we had ever landed a rocket. And you were routinely asked, why would you go to SpaceX? Isn't there these established players that do rocket launch? And saying, oh, well, we're going to land rockets and we're going to be much, much, much cheaper than anything, just kind of got you politely laughed at. There are people we talk to, well, why do I want to change? Helicopter stringing is working. And so there's, I think, a really nice groundswell where we're starting to show, this is the next era of how power lines are going to be built, but it's a risk adverse, very slow to change industry. So we have to demonstrate, and I think we are doing a great job now, that we can meet or exceed the performance levels that people are used to.
I love that comparison to SpaceX, in 2011. I remember those polite laughs back then. And now you think of it today and you're like, yeah, of course you do that. But I love that. And the fact that you've been through that as well, too. You've seen that is a widely accepted, just sort of the normal way. Like, yeah, of course we land rockets. What do you mean? That this technology ability to be very similar to that and you seeing that firsthand as well, too, and choosing to take this as your next venture and see that through, I think says a lot, about the technology and your confidence in it as well. So thinking about those, slow moving industry, slow to change, you got a bit of that. So when customers do adopt the system, and you've had those where it's worked and you're continuing to roll it out, what actually matters most to them? Is it speed, cost, safety, or the ability to build in environments that were previously constrained? Like what's the top couple that they really care about?
So fundamentally, the answer is yes. I think speed, cost, safety, but at the end of the day that we do what we say we're going to do. Because depending on the operation, if we're doing just pilot line stringing, as an example here in the United States, where we put up the pilot lines and then a crew comes behind us to put up the main power lines, that crew does not want to be delayed by us. And if they are delayed or feel that they are delayed in any way, shape, or form, there's both negative repercussions, customer penalties, all sorts of not good. So, you really have to do what you say you're going to do on time, on schedule. So that does mean you're doing things safely because safety is a direct impact to your ability to operate, and you're doing things reliably. These are large, very expensive projects, and the developer or the utility wants them to be done on time.
Yeah, absolutely. I love where you started there. The answer is D, all of the above. We need to take care about all this. But the ROI really is multidimensional across speed, safety, access, fewer constraints, or predictable execution all matter together. And to that point too, I think these folks, especially introducing a new technology, it's like you got to do what you say you're going to do. You got to get it right. I think all that really does is make a huge difference at the end of the day. Looking forward, if you take this out further and technology keeps improving, does it evolve toward a fully autonomous construction model, or is the shift toward kind of like augmenting human crews with far more capable systems? Like, what does the future look like?
So I think what I'll call full autonomous models, probably not in this case. Getting more and more automation to help the personnel on site is really where we're focusing on. Right now, we're moving from pilot line stringing to what we'll call full stack. That's where we show up with power poles and we leave with power lines. As we do that, we're very fortunate to be able to apply a lot of the robotics lessons we've learned in getting the pilot line up to the broader systems that are going on. So that means the polar tensioners that are being used to pull up the power lines, and then a lot of basically connecting the job site. So that's been a really fun area to deploy new technology. I think the second part of this is we are pushing to automate and centralize flight operations. This doesn't mean someone is not going to be looking at a screen flying the drone, but it does mean that there's vision systems helping that pilot get the rope exactly where it needs to be and generally take load off the operators. So I think we've seen that same trend in aviation. The pilots are still there in the cockpit, but they're getting a lot more support from the aircraft.
Yeah, I love that. Again, the human in the loop framing feels very grounded. It makes a lot of sense kind of where you're automating those parts and that as well too. And, truly it's not automation for its own sake. It's safer, more reliable execution is really the goal there. So as you think about this, are you selling technology? Are you delivering outcomes? And how important is that distinction with your utility customers?
Sure. So I think at the end of the day, we are delivering outcomes.
Yeah.
And that's really our main thesis. And to hit the utility, I don't think the utility has any strong preference or care what the technology stack is that went in to deliver the outcome. They care that the outcome was done in a cost-effective and safe manner that met their timelines. So I think, a lot of the software stack, the robotics, everything that's going on here, we could put in a pretty box and say, it does stuff. And as long as it does that stuff safely and reliably, like the outcome is really, really, really what matters. And I think you sitting there, you can appreciate this, where whatever switchgear, conductors, transformers went to make your light bulb turn on, that's all interesting, but the light bulb turned on at the end of the day, and that's what you really care about.
Absolutely. I love that. The distinction's huge. Utilities, by confidence the line can be built safely, cost, effective, on schedule, less risk as well too. So I love that, the focus on outcome. So we've talked about the technology. That's one part of the story, but infrastructure adoption really is about trust. Utilities need evidence, contractors need confidence, regulators need safety cases, crews need training, and customers need to know that this can work not once, but repeatedly across geographies and conditions. Brings us to scale and resistance and what this means if becomes a new standard. So what has been the moment where a customer project made you realize this isn't just incremental improvement, but just a fundamentally different way of building? Any of those success stories come to mind?
In no particular order, we were founded in Australia with a grant because Australia had several major incidents with helicopters. And so it was basically a national priority to say, can we figure out some other way to put up power lines? Australia is also very sensitive in that it's a long, stringy grid. So, Australia had this, we can't build power lines in the normal way, coupled to we really, really, really need power lines. What do we do? And so that's where the company was founded, and really the first flight successes came out of there. And I think what I'm personally proud of is the degree that once a customer sees us in action, or even sees us flying on their competition's event, they're all of a sudden, oh, well, okay, this all makes sense and we want it. So, a lot of our jobs are relatively short initial flights to string a couple kilometers so they could see, oh, okay, you're a trained crew that's showing up on site, knowing exactly what they're doing, and you are doing what you say you're doing. So, it is I think on any continent, it is the repeat order that is always the one that makes you feel like you're doing a very good job.
Absolutely. I think that kind of customer validation is hard to fake, especially in an industry that's naturally cautious about new methods, but they see it works. And then, that repeat business comes in, and I'm sure that helps other cases as well too. The more and more they see that. We've talked a little bit about this. Anything else to add in terms of just what the hardest part of getting the industry to adopt a completely new way of building infrastructure? Any other pieces there?
Well, so it's funny. I think for me, the hardest part, and I look at this internally for a second, is everyone sees the drone and assumes it's the hardest part. And I have to say, because this I find personal, where, at SpaceX, everyone would see the rocket and assume it's the hardest part. The launch pads and all the infrastructure that it took to get this, at SpaceX, very needy rocket fueled, ready to go on time, reliably to launch, was the hardest part. And I think that's really the same case at Infravision, where, our hardest part, people see the drone flying and the pilot's flying it, but he's standing on the shoulders of a lot of giants who helped him fly that on any given day. And so, to me, it's the ground systems, it's the mission planning, it's our investment in procedures and training that I think is what I'll call the underappreciated part, and the one that really, really shows on an ops day.
Yeah, absolutely. Yeah, you could see that as well. And I love that you went there. But yeah, it's so cool and fascinating to see this just evolve, the technology, and then the acceptance happen as well too. I'm definitely excited to see where it goes and follow the story as well. So as we get closer to time, if Infravision succeeds at scale, what does the world look like in 10 years, 20 years beyond? And what does that unlock for the broader energy system?
Sure. So if we do our job right, we're going to be able to put up power lines better, faster, cheaper. And so I think that enables a few things in no particular order. It just enables us to get power to where the demand is. So that enables US industry, whether it's AI or manufacturing. It really helps enable, to the degree possible, green shifts in generation, because chances are the large solar field is in the middle of nowhere and needs connection. So I think that's you're supporting your demand base and you're supporting your generation, which the US does need a lot of new generation. The second part of this is, I think, and you've probably seen this in other people you talk to, progressively the grid is going to very high volt DC, 765 or even 1.2 GV, a high volt DC, which really means you have to build a lot of new transmission, because that's not what exists. And I do think those are going to be the macroscopic modern trends that we see in the US, with much larger, more powerful high volt DC transmission, and the degree to which grid ties start going asynchronous so we can address stability issues. All of that means you need new DC infrastructure, which means we need to get flying.
Absolutely. It's such a much bigger outcome than just faster construction or better construction. It means more clean energy connected, more resilient grids, fewer critical projects stuck behind infrastructure bottlenecks, and just what that will mean for the entire industry and all of energy is just incredible. Final question, I'll kind of open it up. Anything else you want to leave the audience with, things you didn't get to share, any other kind of final thoughts of wisdom?
The big innovative changes often aren't glamorous, and it's a lot of really boring engineering. And I think I'm proud of where we are at Infravision, because it's the outcome of a lot of fundamental engineering to address a really important problem in the world.
Absolutely. Great way to just, we'll put a bow on it there, and great way to wrap up. But Frank, this really was just an outstanding conversation. What I appreciate it about the conversation is it puts transition exactly where it belongs, just at the center of the energy transition and our energy future. If we can't build and upgrade the grid faster, clean energy, AI growth, electrification, industrial resurgence all hit the same physical bottleneck. Thanks for breaking down the challenge, the technology, and what Infravision is building to change the pace of grid construction. To everyone out there listening, thank you for joining Green Giants. If this episode helped you think differently about the future of energy infrastructure, follow the show, leave a rating, and share it with someone who needs to hear it. And check the show notes for some important links as well. With that, we will see you next time.
This episode of Green Giants, Titans of Renewable Energy, was brought to you by Lead Group Search. If you enjoyed today's discussion and are looking to recruit top talent for your company, or find your next career opportunity in the renewable energy sector, visit leadgroupsearch.com. Let's continue driving the future of clean energy together. Until next time, keep pushing toward a greener future.